U.S. Navy launches affordable flash hypersonic weapon program. The Office of Naval Research published a formal solicitation on April 10, 2026, calling on industry and government partners to submit technologies in support of the flight advancement of structures for hypersonics program, a funded, innovative naval prototype effort aimed at developing and flight testing a surface-launched, tactically relevant hypersonic strike weapon. The announcement, posted to sam.gov, marks the Navy's public entry into active industry engagement for a program that Navy leadership selected as an official innovative naval prototype in fiscal year 2026 based on promising technology maturation from prior applied research. Full proposals are due no later than August 17, 2026, with contract awards anticipated by January 29, 2027. The FLASH program, an acronym for Flight Advancement of Structures for Hypersonics, is seeking industry input and technical proposals across 4 critical enabling technology areas: high technology readiness level flight qualified guidance, navigation and control systems and components, high temperature structures and thermal protection systems, scaled design verification and flight test demonstration capabilities, and multidisciplinary design, analysis, and optimization frameworks. The solicitation is structured as a broad agency announcement call under a long-range ONR funding vehicle, with multiple contracts anticipated across all 4 technical areas. Grants are not being considered for this effort. A cornerstone of the program's concept is compatibility with existing Navy launch infrastructure. FLASH is specifically designed to be assessed for compatibility with the vertical launch system and the Virginia Payload module, the standard shipboard missile launcher fitted across the Navy's surface combatant fleet, and a new large-diameter payload section being integrated into Virginia-class submarines. That compatibility requirement shapes the entire vehicle design effort, imposing constraints on diameter, length, mass, and interface requirements that engineers must meet while simultaneously optimizing aerodynamic performance at hypersonic speeds. What sets FLASH apart from other hypersonic programs is its deliberate philosophy around materials and cost. Rather than pursuing the exotic, precision-engineered materials that have defined many prior hypersonic development efforts, FLASH is explicitly focused on demonstrating high performance through advanced aerodynamics while relying on lower-cost, more readily available conventional materials. The program's documentation states directly that the primary focus is to demonstrate a tactically relevant, low-cost hypersonic capability via advanced aerodynamics and control techniques, with a resulting relaxed reliance on exquisite materials. That approach is intended to make the resulting capability more affordable and more readily producible at scale than previous hypersonic weapon designs. Hypersonic vehicles, those capable of sustained flight at speeds exceeding Mach 5, generate extreme aerodynamic heating that places enormous stress on outer surfaces, control surfaces, and internal structures. The FLASH program's materials requirements reflect that reality. The solicitation calls for high-temperature skin materials, carbon-carbon or similar ultra-high-temperature systems, large ceramic matrix composite structures, high-temperature elastomers, metal-based superalloys and coatings, and ablative materials, among other components. Actuation systems, motor technologies, and thermal management components must similarly survive the mechanical and thermal loads generated by sustained hypersonic maneuvering, a capability that FLASH intends to optimize through pitch, roll, and yaw maneuverability to maximize range, lethality, and survivability. Guidance, navigation, and control is another area the program is treating with particular care. Because onboard space, mass, and power are tightly constrained in a weapon of this class, FLASH is seeking existing commercial off-the-shelf and flight heritage GNC components, flight computers, inertial navigation systems, inertial measurement units, GPS receivers, flight termination systems, power systems, and communications hardware that can be packaged within the vehicle's physical envelope while surviving the extreme vibration, shock, acceleration, and temperature environments of hypersonic flight. The program's intent is to use mature, proven GNC components so that development risk can be concentrated on the aerodynamic and aerothermodynamic concepts at the heart of the program. To support that development, ONR is hosting an Industry Day on May 4, 2026, at its headquarters, Bobby Junker Executive Conference Center at 875 North Randolph Street in Arlington, Virginia. The event will be conducted at the controlled, unclassified information level, with attendance restricted to United States persons. Maximum attendance is capped at 120 participants. The technical point of contact for the program is Dr. Eric Marino, Hypersonic Aerothermodynamics, High-Speed Propulsion and Materials Program Officer at ONR Code 352. The contracting officer is Mr. James Farnsworth of the Office of Naval Research. The FLASH program represents a significant step in the Navy's effort to develop an affordable, ship-launchable hypersonic strike capability built on a foundation of advanced aerodynamics rather than costly exotic materials, a combination the service believes can deliver tactically relevant range and lethality within the constraints of existing fleet launch systems.